Welcome to all. Engineering Mechanics Class 43, Part 2. What is Part 2? You can see in the title there. Lecture 2. Basic conditions of static equilibrium for a coplanar force system. In general. See, very important. In general. Note. Already explained earlier. Now, coplanar means all the forces, line of action of all the forces will lie in one plane. And if any couples are there, it will be about an axis perpendicular to the plane. But what we consider is, we will consider moment about a particular point. So, if you take moment about a point, means if I take this point, it is about this axis. So, this sigma m0 actually is sigma mz0, but we don't consider it that way every time. We put simply sigma m0. See here, moment about zz axis. Here you tell moment about any point. Both are same. This already thoroughly explained earlier. Now, coplanar force system means we will consider in xy plane. See this way. This is x. This is y. Now, a note once again, further right. Little later, when you go to strength of materials and also for structural analysis, usually we don't write sigma fx, sigma fy. This xx is actually horizontal. Yy is vertical. Zz is perpendicular to the plane, means widthwise. So that force we are not considering in coplanar. Therefore, little later, instead of sigma fx, we will write sigma h. Sigma fy, we will put sigma v, and sigma m will remain sigma m only. This all I will explain one by one. See, each and everything told in the class, you should go through. Then only the concept will be coming for you. Simply by observing something, you won't learn. Now, see here. Consider a coplanar force system in general. See, x and y, randomly. Forces can be there or couples can be there. See, now, all these forces, if you resolve, you will get one component along x, one component along y. These couples will be about axis perpendicular to the plane, but we take moment about a point. This, okay, now sufficient. See, coplanar force system in xy plane. As already explained earlier, space problem, see same statement. Basic conditions of static equilibrium for a coplanar force system in general are sigma fx0, sigma fy0, and sigma m0. Little later, what we will do? Instead of sigma fx0, this, instead of sigma fx0, later we will write sigma h equal to 0. I will give you once again. Instead of sigma fy0, we will write sigma v equal to 0. And sigma m0 is nothing but sigma m0 will remain sigma m0 only. Sigma m0 only. Okay. Now, this is for a coplanar force system. Now, very important. In a coplanar force system, there are three types. Namely, one, if you see the order of solving problem earlier for resultant, first one is concurrent force system. Second is coplanar force system. Next is parallel force system. So, first is concurrent force system in the order. Second is coplanar force system in general, randomly, see this way. And third one is parallel force system. See, now, in general already I told. Now I will go to particular cases. Particular cases for concurrent force system. I will write in the board. One of the first one is concurrent force system, concurrent coplanar. Second one is parallel force system, once again coplanar. Okay, I will write everything, then I will give summary, then you will seriously go further. Consider coplanar force system. Now onwards, up to end of our study, we will be considering only coplanar force system. As I told you earlier, 3D force system in space or 3D force system, we don't solve questions in the class. Therefore, why it usually in case of building structure solve, it will be always 3D. Software will take care of it. Even manually also, it is very lengthy. So, anywhere it is in the examinations or competitive examinations or even for understanding basic knowledge all, it is not required. So, when requirement is there, you study. Generally, not generally, or generally you can tell. Generally, in structural engineering study, we consider only coplanar force system. See, now, coplanar force system, 3 parts are there. 1, concurrent force system. Concurrent, see, coplanar concurrent, remember. See, everywhere it coplanar concurrent. Coplanar concurrent. See, all forces are passing to one point or common point is there. Even now, it is in one plane. Next. General case, coplanar force system in general, already over. Random, I told. Here, sigma fx, sigma fy, sigma m0. Parallel force system. This all already we considered earlier. Okay, now, again, remember, right here, coplanar parallel. Coplanar parallel. Okay. First, consider concurrent force system. See, example given here, x, x, y, y. Here, for equilibrium, sigma fx0 and sigma fy0. When you go to strength of materials and structural analysis, we will write sigma h0, sigma v0. That's all. I will not tell the same thing again and again. Because you can go to the class repeatedly, go to the class 3-4 times. That's all. Note, sigma m0 is not applicable. You cannot apply it. Reason, I will dictate. For those who are interested to know the reason, I will tell. Or others, remember, concurrent. All the forces are passing to one point. Therefore, there is sigma m0 does not come here. You remember that way. Okay, certain reason I will tell, dictated. Here I will dictate, notes I will write it. See, when a force system is a concurrent force system, all the forces will pass through one common point. Resultant also will pass through the same point. Therefore, if you take moment about this point, moment of all the forces of the given force system is 0, moment of resultant is also 0. Somebody asked me earlier, sir, suppose I take moment about some other point, then it is not 0, no problem. See, no problem, because if you take some other point, do one thing. Algebraic sum of moments of the entire force system about any point is 0. Agreed. That is a basic condition in a coplanar force system. Now you know by Verigno's theorem, algebraic sum of moment of a given force system about any point is equal to moment of resultant about the same point. Therefore, even if I take a point outside, whatever is the moment of the given force system will be equal to moment of the resultant force. For equilibrium, when moment of the resultant force equal to 0 means sigma m equal to 0 is satisfied. So therefore, for concurrent force system, only sigma fx and sigma fy. This is not applicable. Okay, now this is for concurrent. Now I will tell for general already over coplanar. I write it, sorry, not coplanar, coplanar parallel force system. Now, consider coplanar parallel force system. See, x, x, y, y. Once again, remember, this is horizontal, this is vertical. Later, case 1, this way. All forces along y, y. This is case 1. Or, you can tell all forces are in the vertical direction. See, up and down not required for us. Someone long back asked me, sir, in parallel force system, there are two types are there. Yes, which one? Sir, like parallel force and unlike parallel forces. Okay. But you have shown unlike, sir. If it is like parallel force system, I told the answer immediately. Think a little. We are considering equilibrium. If it is a like parallel force system, all the forces will be in one direction. How it can be in equilibrium? Oh, yes, sir. Yes, correct. See, if some forces are acting downward direction, for balancing, some forces are required in upward direction. Sir, but beams, loads are acting down. What about reactions? Oh, okay, sir, sorry. He told, sorry, not me. See, such answer should come immediately. If you know the concept, I don't have to think about it. Why I am not told like parallel force system? A like parallel force system can never be in equilibrium. So, for equilibrium, it should be unlike parallel force system, because whatever forces are acting this way, its resultant should be balanced by the resultant of upward forces. Okay, now, for this, right here, basic conditions of static equilibrium, applicable, very important, applicable are 1. Sigma Fy equal to 0. Net force in the vertical direction or along Yy should be 0. Then there should be no rotation. So sigma m equal to 0. Algebraic sum of moment about any point in the plane equal to 0. Note, sigma fx 0 is not applicable. Why? There is no force in x direction. So even make a note here. Therefore, even though this is a coplanar force system for which you have sigma fx 0, sigma fy 0 and sigma m 0, one of the force conditions vanishes. For this one, sigma fx equal to 0 is not applicable. Suppose you apply, what will happen? Right here, sigma fx equal to 0. 0 equal to 0. Oh, yes, 0 equal to 0. Okay, now, case 2, this way. All forces along xx. I don't have to explain. For this, basic conditions of static equilibrium applicable are sigma fx equal to 0. Yes. Or sigma h equal to 0. Sigma fy equal to 0 or sigma v0 is not applicable. Then there will be no rotation. Sigma m equal to 0. Now, one more is there. See, parallel force system means what? All line of action of all forces should be parallel to each other. All forces can be in x direction along xx or yy. Someone will ask, what about inclined? Okay, done. I will take case 3 now. I will give you case 3. For everything there is answer in structural engineering. Remember, in my class, if anybody asks any doubt, I will give immediately spot answer. I will not ask him, I will tell you tomorrow, wait for some time like that. See, case 3. Case 3. See, all forces are parallel to each other. That is requirement, parallel to each other, but not along xx. Or yy. Means not horizontal or vertical, nor vertical. Or you can tell that is inclined to both xx and yy. Here also, inclined to both horizontal and vertical. That is something like this. See, one force. I will put second force this way. See, parallel to each other. One more force I will put this way. One more force I will put this way. Parallel, remember, here not possible to draw exact parallel. Imagine parallel. Okay. Now somebody will tell, sir, here 3 conditions are there. No, 3 conditions are not there. Only 2 conditions here also. But they will argue, sir, x component is there, y component is there. when you resolve. Don't resolve. Why you want to resolve? Here conditions are basic conditions of static equilibrium applicable are sigma f equal to 0. That's all. Don't write x and y. Simply sigma f equal to 0. That is, I'll dictate here, algebraic sum of all the forces in a direction parallel to the given force system. If all the forces are this way, your sigma f 0 means sigma f here as per this sketch, this way or this way, parallel to this one, sigma f 0. You should write algebraic sum of forces, algebraic sum of all the forces in that direction which is parallel to the given force system is 0. Second one, as usual, sigma m is 0. This is 1. Here, sigma m equal to 0. Okay, no rotation. Now, of course, you can make sigma fx 0 and sigma fy 0. Remember, if you make sigma fx 0, automatically sigma fy 0 will be satisfied. Y means mathematics. Think a little. I won't waste time here. Those who are interested, someone will tell, sir, suppose I make all three conditions. Apply. Okay. When you solve a problem, apply it. Once you make sigma fy equal to 0, what result you get? Same result will repeat when you make sigma fx equal to 0. Then they will tell, oh yes sir, they are all sin theta, here all cos theta, force is same, everywhere sin theta, same theta. If you divide by sin theta, or here if you divide by cos theta, both are same. Therefore, here algebraic sum of forces, what? In the direction of the parallel force system is 0 and sigma m 0. Okay, now I'll give final summary. Little small I have to write because full board I want to give. I want to give the full board so that you can take a screenshot of that one and keep for reference. So little smaller I have to write. If I write very bigger, I have to make 2-3 rounds. No, single screenshot I will try to manage in single screenshot so that you can always refer it. There I will tell you, right now we call sigma fx 0, later we will change it over to sigma h equal to 0. Right now what you call sigma fy 0, later we can change it to sigma v equal to 0. Sigma m 0 will remain same. Okay, now I write everything on the board and then once again explain. Listen correctly what I am telling. There is no space to write each and everything. Some of them I am dictating. What all I dictate, I will tell you write it here in the class. Write it. If I explain generally, you don't have to write. You can still write it. Start first. Final summary for basic conditions of static equilibrium. No 2D, 3D. Start. Force system in 3D or force system in space. See, again remember x, y, z has shown. We will take horizontally lengthwise as x, vertically as y, and this way as z. See, right side, left side, all sign convention later. That's why I have shown x on both sides, y on both sides, z on both sides. Here sign will come later. Don't bother about sign. Simply direction or axis. Okay. Now, for a force system in 3D, sigma fx 0, if you want, you take a drawing sheet and write there. So you can write a statement. Algebraic sum of components of all the forces along xx axis equal to 0. Same way, sigma fy 0, you can write it along yy axis 0, sigma fz 0, along zz axis 0. These three are force equilibrium. See, short I written. You can consider these as force equilibrium. Next, moment equilibrium. Sigma mx, sigma my, sigma mz 0. Algebraic, see, when you go for 3-dimensional force system, Moment is not about a point. Moment is, you are right here. Moment for a 3D force system, moment is about an axis, not point. Those who are serious, write everything. Algebraic sum of moments of the entire force system about xx, see about xx axis equal to 0. See here, this xx axis, this way. Next, algebraic sum of moments of the entire force system about y axis 0. Algebraic sum of moment of the entire force system about z axis 0. These all you can write systematically, make a note. And I have colored it right here. This usually we don't use in the problems later because too lengthy. It's not important. I should not cut here. Write a note here. Okay, don't cut it. Make a note. We will not be using all this one. Okay, now go further. Most important, coplanar force system. Make a note. 3 cases. See, usually earlier I considered concurrent, then general coplanar, and then parallel. Now not that way. Now first general coplanar means random. There is no concurrent condition, no coplanar condition, no parallel condition. Simply forces in any direction. General coplanar force system in general, sigma fx0, sigma fy0, sigma m0. Algebraic, we should write here, basic conditions of static equilibrium are algebraic, after writing sigma fx0 in the bracket, right, that is algebraic sum of component of the end of all the forces of the given force system along xx equal to 0. Sigma fy0, same thing, along yy equal to 0. Fully you right. Sigma m0, algebraic sum of moment of the entire force system about any point, right there, about any, see, I told I am dictating, you write in the bracket here, algebraic sum of moment of the entire force system about any point equal to 0. Later what we will do is, sigma fx0, we will change over to sigma h0, algebraic sum of components of all the forces in horizontal direction equal to 0, in vertical direction equal to 0, sigma m0, same thing, algebraic sum of moment of the entire force system about any point in the plane equal to 0. See, here I am dictating. In the notes I will write each and everything. Okay, now start, 1 over. Coplanar concurrent force system. All forces are passing to one point. Then, right there, some moment term will not come. I told the reason for you. So, conditions are sigma fx0, sigma fy0. Or sigma h0, sigma v0. Just now I explained right here. Algebraic sum of component of all the forces of the given force system along xx equal to 0. Here write along yy equal to 0. When you write here, write algebraic sum of component of all the forces in horizontal direction equal to 0, in vertical direction equal to 0. Okay. Right here, sigma m0 not applicable. Therefore, here 3 conditions, but here only 2 conditions, here also only 2 conditions. Means here you can find 3 unknowns, but here you can find only 2 unknowns. Okay, now, coplanar parallel force system. Class. Right there. Let all the forces be parallel to yy. Class. All the forces parallel to xx. All the forces inclined, but remember, parallel to each other. Whatever this angle, same this angle. Parallel is important. Okay, start. Here, all the forces are in y direction, so no summation in the x direction. So, sigma fy0 and sigma m0. Right here, you should write sigma fx0 is not applicable. Later we will write sigma v0 and sigma m0. Here, sigma fx0 and sigma m0. Sigma fy is not applicable. Later we will put sigma h0 and sigma m0. Here, sigma f0, no resolution required. Algebraic sum of all the forces in a direction parallel to the direction of the parallel forces. See, when it is a parallel force system, all forces are parallel to each other. One unique angle is there. In the same direction, net force equal to 0 and moment of the entire force system at any point 0. Later, same thing. Now and later, both are same. This make a full fair copy. What all I explained, write with proper explanation and be ready. Now next class onwards, we are going for application, marathon application. First I will solve some questions for equilibrium. Then I will go for, see, part 2, different type of loads, point load, UDL, UVL, etc., which we require later. But you study here only. Once that is over, the most powerful support reactions. When you find support reactions, remember, equilibrium is compulsory. So that all will come one by one in order. So subject will be taught, I told, in a systematic order, so that those who study everything without skipping anything, I know so many people are not studying everything, they see partially. You will be the loser. When I put that much effort, and if you don't follow what I tell, or you study your own way, I am not bothered. I told, my class is meant for those who are serious and want to gain knowledge. Dedication is required from your side. Okay, I'll close now because application next class onwards. So today I told summary, all once again explain and final summary given. Next time I'll go for applications, means non-stop numericals. Okay, thank you.